Today's question comes to us from the 2019 Chemistry Trilogy Foundation paper, and it's question 7, and it's all about salts. So to start off with, we've got ammonium nitrate solution is produced when ammonia gas reacts with nitric acid. It says give a state symbol for ammonium nitrate solution. Now bear in mind acids tend to be dissolved in water. The ion which makes acids acid is H+, and that tends to be released when we dissolve it in water. Give the state symbol for it. There are 4 that we need to know at GCSE. We've got S for solid, we've got L for liquid, or what you take on a regular basis, G for gas, and AQ for aqueous solution, and that therefore is our state symbol. The next question says calculate the percentage by mass of oxygen in ammonium nitrate, NH4, NO3. The relative atomic masses are given here, and the relative formal mass of that whole thing is given there. So we have to learn the equation for percentage by mass. And all it simply is the mass of what you're concerned with divided by the mass of the whole thing and times by 100 to make it a percentage. So what are we concerned with here? What is this thing, as I've really scientifically used great vocabulary there? That's oxygen. So if I look at NH4NO3, I have got 3 lots of oxygen. So that means that I've got 3 lots of 16 in there. So let's stick this now into the equation. Our percentage mass is the mass of the thing that I'm concerned with, which is here the mass of oxygen, which we've just worked out is 3 times 16, which is 48. Divided by the mass of the entire molecule, which we get given, is 80, times by 100 to make it percentage. When I work that out, that actually works out at 60%. And that's our answer. The last part of this question, you'll notice I've skipped a few bits out. I wanted to focus on those things which maybe are a little bit trickier and we're going to get a little bit more benefit from. Part F says describe a method to investigate how the temperature changes when different masses of ammonium nitrate are dissolved in water. You do not need to write about safety precautions. So whenever we talk about describing a method, I always want you to think about like you're doing a recipe. Now whenever you do a recipe, the best recipes online have got numbered steps, not a big wodge of text, and they've got diagrams. So, the other tip for method questions is to be specific. So what that means is if you're going to add a chemical, be specific with an amount. So tell us a specific mass or a specific volume. Because that then gives us an experiment to actually action, and also means that we can check if you are keeping something the same. The way that this experiment is going to work is if I'm looking at the temperature changes, that to me suggests that I'm going to have to measure the temperature. So that means I'm going to need a thermometer. And we're doing different masses. So that means whenever we're doing different masses, that means we need to have a step, which means that we repeat for different masses. And it's dissolved in water. So again, thinking about that, we need to be specific with an amount. So you might remember this is one of our required practicals, where you took a polystyrene cup, have a specific volume of water, we measure the temperature of that using a thermometer, and then we add in our ammonium nitrate. Let's put that into steps. Nice and clear, you don't need to waffle. Again, think about experiments like a recipe. So step 1 is take a polystyrene insulated cup and add, again, it doesn't really matter, let's go with 25 centimeters cubed of water. Okay, so I fell into the trap which I always warn students about, which is to make sure that if you're measuring a temperature change, you need to measure the temperature before and after. So once you've got that water in the insulated cup, we're going to use a thermometer to measure the temperature. And now comes our adding of the ammonium nitrate. So add 1 gram of ammonium nitrate, and I'm going to say stir, and again, about being consistent. Remember, we talk about control variables, those things that we want to keep the same. I'm just going to say stir 5 times. So because we're measuring the temperature change, we're now going to measure. So it's not just quite as simple as saying we're going to measure the temperature, because the temperature is going to decrease. So we actually want to measure the extreme minimum of that temperature. So I'm just going to put measure the lowest temperature reached. And then you can say and calculate the change. So this tends to be the point where people go, yeah, smashed it. But remember, we're looking at how the mass changes over time. So then all we need to do is simply say, repeat for 2, 3, 4, and 5 grams, and record those temperature changes. Beautiful. Now, because I've been specific with the water, that implies that I'm keeping the water the same, which covers my control variables. You can be even more detailed here, but I want to get across what you can do. And just remember, those clear numbered steps make it really obvious. We don't need to go into full English or history mode where we're just writing a big paragraph of text. So we have it, our question for today, all about one of those required practicals and a few bits of maths.